is a solution of acetic acid in water. And I don't know the concentration of this vinegar. When you buy vinegar from the store, they tell you in percentage, but wouldn't it be great if we could figure out what the molar concentration of the acetic acid in vinegar was? In order to do that, what we're going to do is a technique called the titration. We're going to do essentially an acid-base reaction, an acid-base neutralization. So a mole of sodium hydroxide reacts with a mole of acetic acid to form a mole of sodium acetate and a mole of water. And if we could imagine adding exactly the right amount of sodium hydroxide to exactly neutralize the amount of acetic acid we had, right? So we could actually count the number of moles of sodium hydroxide, and we'd know how many moles of sodium hydroxide we had added to exactly neutralize the number of moles of acetic acid we had in the container. Okay? If we could do that, then we'd know how many moles of acetic acid we started with. And if we know what volume of vinegar we started with, we would then know the concentration of the acetic acid in our vinegar solution. So what's the key? The key is that we have to know how many moles of sodium hydroxide we've added, and we have to know the volume of the vinegar we start with, and we have to know the stoichiometry. We have to know how many moles of the sodium hydroxide react with how many moles of the acetic acid, and in this case it's 1 to 1. And this is called an acid-base titration. So let me show you the process. First, the tool that we're going to use is something called a burette. And this is a burette. It's a straight glass tube that's graduated. It tapers down to a point. Sometimes this point gets clogged, and you can just clear it out with a piece of wire, but that's not too common a problem. And then there's something called a stopcock. This is a Teflon stopcock, and basically it's the on-off valve. So when it's open, liquid flows through this glass tube and into the tip, and when it's closed, it shuts off. And let me show you, take this apart and show you what it looks like. The Teflon stopcock comes in 4 pieces, and one piece is called the barrel, and it has a hole that goes all the way through it, and you'll notice that the handle is lined up with the hole. So right now the hole is going up and down. And so that's how you can know when it's on and off. This is the on position, and that's the off position. So the barrel goes into the burette, and then there's a white Teflon washer that goes on first, and then a black rubber O-ring goes on second, and then the knurled nut goes on third, and screws on. And you want to get it snug, but not too tight. Okay? And you can play with it a little bit until it's sort of the degree of tightness that you prefer. Okay, so we clamp the burette in a burette clamp. So this is a burette clamp. Squeeze these handles here, and that's what holds the burette in place. There are various types of burette clamps, and what I have here is a funnel at the top, because we're going to have to pour sodium hydroxide into this tube, and we don't want to have to try to pour sodium hydroxide into the little tiny opening here. All right, so let's get the vinegar out of the way, and we're going to take our sodium hydroxide. This sodium hydroxide is of known concentration, and that's important. You have to know the concentration of your sodium hydroxide. You may have to standardize it, which means you may have to measure the concentration of sodium hydroxide. In this case, we just know ahead of time that the concentration of sodium hydroxide is 0.502 molar. Now, obviously, if we know the concentration and we know what volume of sodium hydroxide we add, then we know the number of moles of sodium hydroxide we've added. So the first thing I would suggest is that when you come into the lab, it's a good idea, set up your burette, and then pour a little bit of sodium hydroxide into the burette to rinse it out. Now, you don't know what other people have been using this burette, where it's been, right? So add a little bit, wash down the sides, and when I say a little bit, I mean a few milliliters, and then drain out that sodium hydroxide. And if it doesn't drain out, what you can do is add a little more, and there we go. Okay, so we're going to just let all of that run out, and we're just going to discard that. That's nothing. Almost there. Sometimes you do have to be a little bit patient with these.
Dad, I'm coming! I'm coming!
can see that it's taking a long time to swirl away the color. Okay, so that's it. That's actually probably even just a little bit past, but I only added the tiniest volume.
Wait, I'm coming.
Maybe a 20th of a milliliter by flipping that up. So that's a little bit past, but that's pretty good. And the final volume is 39.15. 39.15. Okay, and that's milliliters as well. All right, so now what do we know? Well, we know the initial volume of vinegar. We know the total volume of the sodium hydroxide we've added. So we know the number of moles of sodium hydroxide because we also know the concentration of sodium hydroxide that we've added. And so we know the number of moles of acetic acid we had in our original vinegar because we know the number of moles of sodium hydroxide we've added. And in the graphic, what you'll see is the completion of this calculation to calculate the volume, calculate the concentration of acetic acid in our vinegar.